We're going to look today at how we name compounds from their formulae. This is a really important idea in chemistry and one that people often don't actually spend enough time learning. If we learn it early enough, then we can actually have we'll actually find chemistry a lot easier in the long term. And we're going to look today at naming compounds, first of all, that are made of metals and non-metals. A couple of words on it before. The names of any elements and any compounds are common nouns, so we shouldn't capitalize them. So for example, if you see the word lithium chloride written, that's actually incorrect because it's a common noun, so we should be using a lowercase. The only exception to that would be if you were writing at the beginning of a sentence. So it's a lowercase lithium and a lowercase c, although we do recognise that we could probably have a go at working out the formula for that, and it would be LiCl. We do need capital letters at the beginning of the element symbols there, but when we write the name, it's with a lower case. So last time, hopefully you remember, if we look at the periodic table, and I'm just going to sketch really briefly the periodic table up here, then we hope you drew this stair line, or you've seen this stair line on the periodic table, and all of the elements on the left of that line are metals, and on the right are non-metals. And we're going to be looking at compounds that are made up of a metal and a non-metal atom bonded together. So our first example is KBr. The first thing we'd have to do is look on the periodic table, and we'd find out that that is the symbol for potassium, and this is the symbol for bromine. Now when we name this compound, the first part of the name stays exactly as we started with. So K is potassium, so the first part of the name here is potassium. Now the second part, the non-metal part, and the non-metal will always come second, we change the end of that name from INE to IDE, ide. So we go from bromine to bromide, and we'll see that with any single example, that we change the name of the non-metal from bromine, from INE, from ene sound, or the YN sound at the end of oxygen, to ide. Let's have a look at example number 2 and 3. So we've got some numbers here. The numbers make no difference to the name for these metal non-metal compounds. All we do is do exactly the same thing as we did last time. We recognise and we check that we remember that that is the symbol for magnesium, and that is the symbol for chlorine, but the name is first of all made up of magnesium, which is the first part, and chloride. So we change the name of chlorine to ide. The reason we do that is to show that it is in a compound. And remember, again, I'm using lowercase letters at all times when I'm naming my compounds. Again, same process here. There's a number here, that makes no difference. All we do is we look at the two elements that make this up, and we see that this is lithium and this is oxygen, so the name becomes lithium oxide. So we go from the YGEN at the end to ide, so we get lithium oxide. Okay, there are 12 questions here. If you would like to copy them down, I'll pause the video for a moment. I'll stop speaking for a moment so you can pause the video and then have a go at doing those questions in your book or on a piece of paper. Okay, so there are the answers. If you want to pause the video again. If you manage to do the challenge questions, really well done. So the nitrogen becomes nitride, the selenium becomes selenide, and the tellurium becomes telluride. Those ones are quite difficult. I'm just going to say the name of each of these out so that you know how we pronounce them. So that's lithium bromide, sodium iodide, calcium bromide, iron oxide, vanadium oxide, copper fluoride, and chromium oxide. And I'll say these one more time: chromium nitride, sodium selenide, potassium telluride. There are some special cases. and these are sulfates, nitrates and carbonates. If we ever see at the end of a compound this group here, this SO4, we would name this sulfate, and it's only if we see something followed by SO4, we call that a sulfate. If we see a metal followed by NO3, we name that nitrate, and if we see a metal followed by CO3, we would name that as carbonate. Later on in your study of chemistry, you will understand why this is SO4, NO3 and CO3, and also some more things about it and how we'd go the other way, so how we would take a name and write a formula. But for now, we're just going to have a look at naming them. So, copper carbonate. So what I did here was to recognise that this Cu is the symbol for copper, and I saw CO3, so I called this copper carbonate. Let's have a look at this one here. Now we've got Na2SO4. This 2 makes no difference to the name. The first part of the name is going to come from the metal, which is sodium, but we see this special SO4 group, SO4 here, so we would call this sodium sulfate. Then we have a look at our last example. We do the same thing as we did last time. We look at Cu, which is the element symbol for copper, and we see NO3, this special NO3 group, which is the nitrate, so we would call this copper nitrate. Okay, have a go now at these questions and pause the video, and when you're done, here are the answers. I'll say these names so you know how they're said. Potassium sulfate, lithium nitrate, calcium carbonate, lead sulfate, rubidium nitrate, manganese carbonate, strontium carbonate. Might be worth you going back on all the ones that you've written down today and having a go at saying them out loud. That's something we would be doing if we were in the classroom. There's another special set of cases, and these are non-metal oxides. So if you were to have a look at example number 7 here, example number 7 is made of sulfur and oxygen. If we were to have a look at the periodic table here, there's a periodic table I printed off. It's a bit different to the one in your books, but if I just draw the stair line on here, so hopefully we recognise that all of the elements on this side are metals and these elements are non-metals. If I just zoom out so you can see the whole periodic table here, then actually this oxide is made up of sulfur and oxygen. So this is a compound between two non-metals, so the naming system is going to be slightly different. So the name of this is sulfur trioxide. So how are these different? Well, we show the number of oxygen atoms present in the name. So if you see what I did here, this tri means 3. So this name, sulfur trioxide, SO3, I've named it because S gives it sulfur, the tri tells us there's 3, and the oxide tells us that those are oxygens, so sulfur trioxide. So before we start this, we're going to have a list of the prefixes, and the prefixes are the words we put in front of the oxygen, or it can be other elements, to tell us how many there are there. So we put mon in front of something, which comes from mono to mean 1, di for 2, tri for 3, tetra for 4, and pent for 5. We're not going to see any examples that go beyond that, but just if you want to, then I will go up to 8, and you might start to recognise some of those names, particularly the 6-sided shape is a hexagon, 7-sided is a heptagon, and an 8-sided is an octagon. So these are Greek number prefixes. So let's have a look at another 2 examples. This compound here is made of nitrogen and oxygen. We change the end of the oxygen to "-ide", and we say how many there are. In this case, there's only one of them because there's no number after it, so we assume it's 1. So this one would be nitrogen monoxide. This example here, because we've got 2 nitrogens and 4 oxygens, we would actually call this compound dinitrogen. So dinitrogen tetraoxide. We might sometimes see that rewritten slightly as dinitrogen tetroxide. Both of these have actually been used. Either would be acceptable for us at this level, so it just removes the 2 vowels next to each other there. Before we move on to some questions, I just want to have a look at the spelling of phosphorus. This is actually often incorrect, even in some textbooks. The element phosphorus is spelled as you see there, US at the end. If phosphorus is in a compound, and I'm going to give you an example here of PCl3, then the name changes to phosphorus, OUS. In this case, this would be phosphorus trichloride because it's a non-metal. So then, just so that we know that the name and the element ends in US, and if it's in a compound, it's spelled OUS at the end. So there are some questions. If you'd like to pause the video and have a go at those questions. And then here are the answers. I'm just going to talk through the names again so that you are familiar with them. Dinitrogen monoxide, carbon dioxide, carbon monoxide, nitrogen dioxide, sulfur dioxide, sulfur trioxide, disulfur monoxide, dinitrogen pentoxide, and diphosphorus pentoxide. Notice that I've spelled that OUS because it is in a compound. Thank you very much.